So you've probably seen them, right? Those little blue circuit boards that are all over the internet. They're powering everything from blinking lights to really complex robots. And you've probably wondered, what is that thing? Well, you have come to the right place. Today, we're going to demystify the amazing world of Arduino, especially for complete beginners.
Okay, so here's the game plan. First, we'll get a handle on what Arduino actually is. Then we're going to take a tour of the board itself, learn the basics of its language, build our very first project, and finally, we'll look at all the cool possibilities that open up from there.
All right, let's dive right in. What is this little device that has kind of become the heart and soul of the whole maker movement?
That's the big question, isn't it? And you know what? The answer is actually pretty simple, but it opens up this entire world of creativity.
This right here nails it. The best way to think of an Arduino is as the brain for your project. You give it a set of instructions, that's your code, from your computer, and the Arduino acts like a bridge, turning those digital commands into real-world actions. You know, like making a motor spin or checking the temperature in a room.
Now, Arduino isn't just one single board. It's a whole family. The Uno, that's the classic, the go-to for beginners. It's got everything you need to start. The Nano, it's its tiny cousin, perfect for when you're trying to cram your project into a small space. Then there's the Mega. That's the powerhouse for when you need to connect a ton of different things. Oh, and because Arduino is open source, you'll see clones everywhere. They're basically the same thing, just cheaper, which is always nice.
Okay, so let's get up close and personal with the board itself. It might look a little intimidating, but we're just going to focus on the key parts you really need to know. You see that big black chip, usually right in the middle? That is the heart of the entire operation. It's the microcontroller. Just think of it as a tiny, dedicated computer whose only job in life is to run the code you give it over and over again.
So how do we talk to this little computer? Well, that's where the USB port comes in. It actually does two jobs. It gives the board power to run, and most importantly, it's how you upload your code. And that little chip right next to it, it's kind of like a translator, converting the code from your computer into instructions the microcontroller can understand.
So all those little holes lining the edges, those are called pins, and they are how the Arduino's brain connects to the real world. They fall into a few camps. You've got your digital pins, which are like light switches. They're either on, which we call high, or they're off, which we call low. Then you have analog pins. They're more like a dimmer switch. They can measure a whole range of values, not just on or off. And the power pins? Well, they're exactly what they sound like. They provide the juice to run everything else.
We've got the hardware down, so now let's talk about the software. How do we actually write the instructions to tell this brain what to do?
In the Arduino world, your program is called a sketch, which is a pretty friendly name for a piece of code, right? You write it in something called the Arduino IDE, which is just a free piece of software you can download, and the language itself is a simplified version of C++, which makes it way easier for beginners to get the hang of.
And here's the thing. Every single Arduino sketch has this basic two-part structure. First, you have the setup function. The code in here runs only one time, right when you power the board on. It's for getting everything ready. After that, it jumps into the loop function, and it does exactly what its name says. It runs the code inside it over and over and over again, forever until you unplug it.
Theory is great and all, but let's actually make something happen. It's time to write our very first sketch and bring our Arduino to life with the absolute classic first project, Blink. And honestly, you'll be shocked at how simple this is. In our setup section, we use pin mode to tell pin 13 that its job is to be an output. That means it's going to send a signal out to control something. And what's super convenient is that most boards have a tiny LED built right onto that pin. Then, inside our loop, we use digital write to set that pin to high, which turns the LED on. We delay for 1,000 milliseconds, that's 1 second, then we use digital write again to set the pin low, turning the LED off. Wait another second, and the loop just starts all over again. And that's it. You've just programmed a blinking light.
So, a blinking light is kind of the hello world of electronics. It's the first step, but it's just the beginning. Let's see how these exact same ideas can build something way more impressive.
Check this out, a Sonos scanner. It uses the same concepts we just learned. The Arduino Uno is still the brain, but now it's connected to an ultrasonic sensor. Think of it as the project's eyes to measure distance. It uses a servo motor as a neck to look around, and it even has an LED and a buzzer to act as its voice, to tell you when it sees something. See? Each part has a simple job, all controlled by the brain.
And don't let this feel overwhelming. As Robotics, the person who made this project, points out, you really don't need months to build awesome things. Once you get these basics down, you could totally build a project like this Sona scanner in just a weekend.
So there you have it. The Arduino is the brain, the code is the language you use to talk to that brain, and the pins are how it interacts with the world. You now have all the fundamental concepts you need to get started, so the only question left is, what are you going to build?